we draw a line there, that red line across at 2 degrees C, and we hit the blue line right there, like that comes down to, that's like the conservative side of this green number 1 scenario, which brings us down to about 450, and this is total greenhouse gases, CO2 equivalent. And so this is another concept. There's a difference between CO2 levels in the atmosphere, and then sometimes people talk about also CO2 equivalent, which is where they sum all the other greenhouse gases minus, or including also the contribution of aerosols. And so aerosols are that black particulate matter in the atmosphere, which is bad for health impacts, but has a net cooling effect. So it actually masks the situation. So we're contributing methane and other greenhouse gases, and then we're also adding in the negative component of aerosols and coming up with one number that we use in terms of CO2 equivalent. We should be at about 450 CO2 equivalent, which is about 350 to 400 ppm CO2. IPCC, for any of these in this range over here, they didn't find any published results for technological solutions that would get us there. There just were no published results that said we could do it.
I have a question.
Yeah.
Leah. Do you know if in the CO2 equivalent number, in that projected number, if one of the assumptions is water vapor, is that included in there at all?
No, it doesn't include water vapor. That's a feedback. We're talking, like, basically 450 CO2 equivalent is where we are right now, if not below. It's 350 to 400 CO2 levels, and we're at 389. So what this means basically is, for us to get there, we need to go to essentially zero emissions today, right now, right? There's some help here that we have from the natural world, right? So we don't actually mean zero emissions. We could be at 60 to 80% reduction, and that remaining 20 to 40% is what the natural world right now has the ability to take up, mostly in the oceans and some in the carbon cycle. Yeah, and then we know as we get into the future, we lose some of that ability as the oceans warm up. But so as this is telling us, we want to be at 60 to 80% reduction of our emissions right now, today. And so, since this clearly isn't going to happen, the plan B is that we should plan on overpassing this 450 target, and then get there as soon as we can. So we're not going to hit 450 CO2 equivalent today. Get there as soon as we can, and then make up for the fact that we've overshot it by dropping our emissions even faster after that. So putting us on a negative growth, a really steep negative growth curve. So do you guys get this? This is kind of complicated. Like, we should be doing it today. Since we're not doing it today, we should get there as soon as we can, and then sort of make up for our tardiness by dropping emissions even faster, and kind of hoping that we can get our emissions back down to a low enough level soon enough that, like, the climate system doesn't catch up and didn't get it, and that the CO2 that is up there is we're gonna bring ourselves back down to still keep us below that level. Does that make sense?
Yeah.
Yeah. So this is sort of the plan B that we've got here. Like, do it late, but better late than never, and then make up for it by really ratcheting down. And one study says that if we don't get to this, if we don't reach our peak greenhouse gas emissions and then start going on the downward track until after 2020, we're going to have to put ourselves at reduction rates at over 5% less CO2 emissions every year in order to stay under 2 degrees C. Which, since right now we're growing at 3.5% a year, like...
That doesn't seem...
Right. No. Yeah, that we'd have to be on a negative 5% growth rate per year to do that. Scary. And so this is, then we go to slide 19, and just, this is another way of looking at it. It's a little simpler. So this is these 15%, 50, and 75% probability of keeping us below 2 degrees C. And so this is, if we get to 550 ppm CO2 equivalent, we still have a 15% chance of staying below it. 450, a 50% chance, and 400, a 75% chance. And there's the zero line right there, which actually means at some point we go into negative emissions, which means we're not producing any CO2 and we're using carbon sequestration technologies to pull carbon dioxide out of the atmosphere. Yeah. Okay, look, I got this idea from Alicia.
Yay!
Puppies! Doesn't that make you guys feel better? Look at that puppy! I thought we could use a break.
Shit.
I don't want all the puppies to die.
Look what you did. So Reb,
Let's carbon more
getting
puppies.
close to the window.
Yeah, we're almost done.
Yeah,
We're
cool.
wrapping up
Actually,
right
I've
now.
got to go do outreach because it's Maine, but thank you.
Go ahead. You want to see a kitten?
And I got to drop my
Oh, kitty.
You want to see another kitten?
Yeah.
Okay. We need a little pick-me. Okay, now let's put so we're on slide 23 here, everybody. And so let's just talk about, I'm seriously depressed if I wasn't have this kitten right here to look at. Like, this, it totally sucks. Like, we're so far from, what's happening in Copenhagen, particularly since nothing sounds like it's really going to happen in Copenhagen. So let's talk about, are there any take-homes here, like, that really apply to Copenhagen? And, let's go back here. There we go. So, how can a science perspective still contribute to Copenhagen? Like, can it at all? And so I've come up with a few just a few things to keep in head, especially for you three when you're actually going to Copenhagen, like, that science can still play a role. And I'd love to, if you guys want to contribute what things you see too, that, like, can still help these negotiations. So the first one is knowing that there is inherent uncertainty in the climate system, right? That, like, X CO2 doesn't equal Y temperature. We just can't know that. There's these inherent uncertainties here that come mainly from the tipping points and the positive feedbacks. And so we have to kind of, like, plan on that. And, like, so we don't have a lot of wiggle room, but we need to think about the fact that there's this uncertainty that's part of this system. Second one is the concept that there's warming in the pipeline, right? So that actions we take now aren't going to see results for several decades to come. And so I think that's something that is a difference in a science perspective and a political perspective too. That, like, we think of actions now and results tomorrow, and the climate system doesn't work that way. There's a lag time, that commitment warming. And then thirdly, that there is serious long-term inertia in the climate system in terms of these long-term feedbacks like ocean expansion, sea level rise, and ice sheet melt particularly. Those are the really long-term ones that then make the fact that the decisions we make now are going to determine our climate for centuries to come. And, like, that's such a hard thing to keep in your head. I think that's a really important thing to try to think of, like, negatively, if you look at it, like, the mistakes we make now are going to impact generations to come, but positively, we have a window of opportunity now to make decisions for, so this is even more critical to do something now. And then, lastly, because basically we're there already, we're at that 2-degree threshold now because of commitment warming, that we need to not just be thinking about mitigation, we also need to be thinking about adaptation as part of the picture, and helping, because, we're committed to some of this already, and we need to figure out how to adapt to it too. And that's it.
Right.
Phew. I'm sorry that I went this
Alan, I have a quick question.
Thanks, guys. Go ahead, Alan.
How does the number of 350 fit into this? Are there any legislation on any level that's been
No.
introduced with 350 as a target?
No. 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 That was the whole problem. That's why I wrote the whole science report and the whole blog, like 3-part blog posting on 350, because it's, science-wise, it's great, and there's actually science backing, considering these long-term inertias that says that 350 is, way better than 450 in terms of where we want to be to keep ourselves below 2 degrees C. But it gives us a way better chance of staying below it, but it's just so unfeasible that, it's not being talked about.
Yeah, and just to put this talk in context of the next talk that Jesse Jenkins will be giving us. So Reb has done a fantastic job of laying out all of the logical steps that lead to setting up targets for these international negotiations.